Hey guys, this looks like a fun one. It says find the area of the red region. So we want the area of the region contained by these three circles. And these circles have a radius of 1, 2, and 3 meters. So for the first step, let's connect this center to this center, and then this center to this center, and then this center to this center. This forms a triangle, and let's look at the triangle down here. So this is a radius of this circle, which is 1, and this is a radius of this circle, which is 3, which makes this entire top side 1 plus 3, which is 4. And same here, this is a radius of 3, and this is a radius of 2, which make this whole bottom a length of 5. And then this radius is 2, and this radius is 1, which makes this side a length of 3. So this is a 3, 4, 5 triangle. That is a Pythagorean triple. That means this has to be a right triangle. And here's the Pythagorean theorem that verifies it. All 3, 4, 5 triangles are right triangles. Let's find the area of this whole triangle. The area of a triangle is 1/2 base times height. So if we rotate this thing, we can see that the base is 4 and the height is 3. 4 times 3 is 12, and 1/2 of 12 is 6. So the area of this triangle is equal to 6. So now that we have that, let's look at these individual pieces of the triangle. We have this yellow sector right here, this orange sector, and the green sector. Let's start by finding this orange piece. If this central angle is equal to d, the area of this sector is going to be equal to d over 360 times pi r squared. And we know this is a right angle, so that means we can plug in 90 for the d. And the radius of this circle is equal to 1, so we can plug in 1 for r. 1 squared is equal to 1, and multiplying by 1, we don't need this 1 anymore. 90 over 360 is equal to 1/4, so we end up with 1/4 pi, or pi over 4. Next, we have the area of this yellow sector. Let's make this angle d degrees so we can use this formula right here. The radius of this circle is equal to 3, and 3 squared is equal to 9. Now we got to find the d. Let's copy this triangle down again, and this right here is the angle d. So now we have to use some trigonometry. We know that sine of d is equal to the opposite over the hypotenuse. The side opposite of the d is equal to 3, and the hypotenuse is equal to 5. So now to solve for d, we need to do the inverse of sine. This sine inverse gets rid of the sine, so we just have d on the left-hand side. And for the sine inverse of 3/5, we can use a calculator to get the approximate value of this, and we get 36.9 degrees. And so we can change this d into 36.9. So unfortunately, this isn't exact anymore, so we got to make this an approximately equal. After we do all this math, we get the area is approximately 2.9. And last, let's do this green sector. So we'll make this angle right here d, which means we can use this formula again. For the r, the radius of this circle is equal to 2, and then 2 squared is equal to 4. And now to find the d, we know that the three angles of a triangle add up to 180 degrees. So 90 plus 36.9 plus d will equal 180. 90 plus 36.9 is 126.9. And after we subtract that from both sides, we get d is equal to 53.1. And we can change this d into 53.1. And then once again, we got to change this to approximate. And after we do this, the area is approximately 1.9. And now we have everything we need to find the area of this red region. It's going to be equal to this large triangle, minus the yellow region, which was approximately 2.9, but here's the exact value right here, minus the green region, which is approximately 1.9, but this is the exact value for the green region, and then minus the pi over 4, which this is the exact value. And after we do all this math, we get approximately 0.464256 meters squared. And these are the answers to the question. This is the exact area, and this is the approximate area of the red region. How exciting.